Have you ever thought about the human body as like the most incredible piece of architecture ever designed? I mean, you've got bones for structural beams, nerves for electrical wiring, but what about all the surfaces? The wallpaper, the protective siding, the tile floors. Well, today, we're exploring the master material that does it all. Seriously, think about it. What is the one single material that covers your skin, lines your mouth, your airways, and even the inside of your blood vessels?
The thing is, the answer is so much bigger than just skin. We're talking about a living, breathing fabric that creates a boundary, not just between you and the outside world, but between all the different compartments inside your body.
Okay, so let's roll out the blueprint. We are diving into your body's essential lining. We're going to get to know epithelial tissue, the true, unsung hero of your body's design. But first, before we zoom way in, we need to kind of get the lay of the land, See where this tissue fits into the grand scheme of things. Because like any great building, your body is put together in a really organized, step-by-step way. It all starts small, with the cell, the basic unit of life. Then groups of similar cells team up to form tissues, each with a very specific job to do. From there, these tissues assemble into organs, like your heart or your kidneys, and finally, you've got organs with related functions grouping together to create entire systems, like your digestive system. Today, we are parked right at that second level, tissues. And we're focusing on one tissue in particular, the one that acts as your body's interface with, well, everything. You can almost think of it as your own custom-made living wallpaper. So what is it exactly? Well, epithelial tissue is basically a sheet of cells that are packed together incredibly tightly, side by side. They form the outer layer of your skin, that's the epidermis, and they line all of your internal cavities in tubes, from your airways all the way through your digestive tract. Now, any good building material has a spec sheet, right? A list of its key features. And epithelial tissue is no different. First, notice how the cells are jammed right up against each other. That's called high cellularity. There's almost no space between them. It also has what we call polarity, which just means it has a distinct top and a distinct bottom. But here's the wild part. It's avascular. See how there are no blood vessels in that top layer? It has zero blood supply of its own. So you're probably wondering, how does it stay alive? Well, it gets all of its oxygen and nutrients by diffusion from the connective tissue right underneath it. That's where all the blood vessels are. This is also why a paper cut stings it like crazy, because it has nerves, but often doesn't bleed. You've only nixed this avascular layer. Okay, so just like an architect wouldn't use the same material for a skyscraper's foundation as for a bathroom floor, your body uses different kinds of epithelial tissue for different jobs. Let's flip through the catalog. The first way we organize them is super straightforward, by the number of layers. If it's called simple epithelium, that means it's just one single, solitary layer of cells. It's built to be thin, making it absolutely perfect for jobs where things need to pass through quickly, like absorbing nutrients. On the other hand, if it's stratified, that means you've got two or more layers stacked up. This design is all about protection, durability. It's like a reinforced wall built to take a beating. The second way we classify them is by their shape. You've got squamous cells, which are flat, kind of like little floor tiles. Their thin shape is ideal for diffusion. Then you have cuboidal cells, shaped like little cubes or bricks, great for lining tiny tubes and ducts. And finally, there are columnar cells, which are tall and slender like pillars. That extra height gives them more room inside for complex jobs, like producing mucus. So the key here is that by combining a layer type with a cell shape, your body creates this huge catalog of highly specialized linings. So, let's see how this catalog actually gets used. We're going to take a quick tour of the body and see where these specific materials are installed and why they are absolutely the perfect fit for that location. First up, we've got the thinnest, most delicate material in the entire catalog, a single layer of flat tiles. This is simple squamous epithelium. Its whole design philosophy is speed and efficiency. Because it is so incredibly thin, it creates the shortest possible path for things to get from one side to the other. There's no time to waste. And that need for speed tells you exactly where you're going to find it. In the deepest parts of your lungs, it lets oxygen and carbon dioxide zip back and forth. As the super smooth lining of your blood vessels, we call that the endothelium, it lets nutrients and waste pass in and out. It also lines your major body cavities, where it secretes a lubricating fluid so your organs can slide around without friction. All right, now let's jump to the complete opposite end of the spectrum. Let's look at stratified squamous epithelium. We are going from a single, thin tile floor to a multi-layered brick wall. Exactly.
If simple squamous was all about easy passage, this tissue is a barrier. Its job is to take a beating, to withstand friction and wear and tear, all to keep the more delicate tissues underneath it safe and sound. We find this stuff in two main varieties. There's the keratinized or dry version. This forms the outer layer of your skin, the epidermis. Its top layers are literally dead cells, packed with a tough protein called keratin, creating a durable, waterproof barrier. Then you've got the non-keratinized or wet version. This lines places that see a lot of friction, but have to stay moist, like the inside of your mouth, your esophagus, and the vagina. Okay, but here's where it gets really fascinating. These tissues, they aren't static. They're not just set in stone. They are living, dynamic structures that can actually change and adapt based on their environment. And sometimes that change isn't for the better.
This process is called metaplasia. It's what happens when your body, dealing with some kind of chronic stress or irritation, decides to basically swap out one type of epithelial tissue for another, tougher type. It's a survival tactic, an adaptation. But it comes with a serious trade-off.
The absolute classic example of this happens in the airways of a heavy smoker. A healthy airway is lined with this beautiful, specialized columnar epithelium that has cilia, these tiny little hairs that are constantly sweeping mucus and trapped debris up and out of the lungs. But under the constant assault of cigarette smoke, the body does something drastic. It replaces that delicate ciliated lining with a tough, multi-layered stratified squamous epithelium. Now, this new lining is way more resistant to the smoke, but it has no cilia. That protective self-cleaning function is completely lost. And here's the crucial takeaway. While metaplasia is a pretty clever survival mechanism, it comes with a major risk. This cellular renovation is often reversible if you remove the irritation. But if that stress continues, this adaptation can be the first step on a very dangerous path towards more serious, uncontrolled cell changes.
So, in the end, the story of our epithelial tissue is a story about boundaries, about protection, and most importantly, about adaptation. It shows us that the very architecture of our bodies isn't fixed, but is constantly responding to the world around us and the choices we make every single day. So that really just leaves one question. What choices are shaping your internal architecture?